I have an it is
Okay.
up and running. I've just imported, and the command to check the status is ng state. When I do that, it says online.
Okay.
I don't let my developers access this site. So I don't let my developers log into my Netezza server, host server, because there's a
Right.
customized one. I don't want my developer to play around on it. Now, what is the solution I
Okay.
have? I have to install the clients. So if you are using a Windows box, I'll install a Windows client, and if you are using a Linux or AIX or HPX, so I'll install the respective Netezza clients for you,
Okay.
right? So that's where these clients come in picture. If you look at here, Netezza client components.
Okay. So in this case, Ravi, so we have you have given me two client components. Client components 7.2 for Windows 7 and for Linux.
Right.
So I need to install the Windows one because since my client will be a Windows machine.
Yeah, you can download both. Linux also
Okay.
is there if time permits during the sessions. We'll
Okay.
create one more VM and we'll install the Linux components and we'll try to communicate
Okay.
from Linux to Netezza
Okay.
host.
The software emulator for developers is nothing but it will act as a server.
Server host.
Then it is a server. Okay.
Mhm. So these file sizes are big. The emulator is somewhere like 4 GB, I guess.
Okay.
Right. The other day we spoke about Netezza architecture. No
Correct.
questions there, Siddharth.
Should we give a recap, Ravi, on that?
Yeah, okay. Let me do a quick recap. After that, I'll go through these 5 to 6
Okay.
questions. We spoke about various terminology the other day. First one is I said that we have a 10,000 series in the past. After that, we have a 1,000 series. After that, we have 2,000 series. After that, we have a 3,000 series.
Right.
This 10,000 series is called Mustang. This is called Twin Fin or Macro. This is the hardware model. So this is 4.6, 7.0, 7.1, 7.2. This is software versions. This is for branding purpose. The fundamental architecture we did analyze the other day was for TwinFin. Why TwinFin? Because
Right.
it is where it all started, the high availability architecture. The ratio of 1 is to
Right.
1 started from here, even though we don't have that ratio anymore, it's hyper and macro. So this is what we looked at in TwinFin. Three major components. On top we have a storage. In middle we have a host. At the bottom I have blade servers. Yes. So what do I have on the host is I have two hosts. Irrespective of it, whether I am using a twin fin or a striper or a macro, I have two hosts. One active, another one passive. These are Red Hat Enterprise Linux hosts, which provide
Okay.
high availability. If one goes down, the other one will pick up automatically, or you have an option to fail over manually as well.
Okay. So these are the Red Hat Linux hosts.
Yes, Netezza took that Netezza, RHEL source code, and they customized it for Netezza needs.
Okay.
These are Linux hosts.
And and this contains automatic failover also.
There is a clustering in between them. So for example, one host we call it as ng prod A, the another host we call it ng prod B. So if
Hmm.
A goes down, you'll automatically go to B. But what you have on top of here, each one has its own IP address. For example, 192.134.181.23. So on top of it, from administration side, they give you ODBC IP. So this IP
Okay.
is only that something that you see. It connects to whichever is active host,
Got it.
right? It's not a continuous
Yeah.
availability. It's not like failover that you can't see the effect. There is a downtime. If this host goes down, there is a downtime for you to switch from ng prod A to ng prod B. There is a switch.
Okay. So that it does automatically, right?
Yeah, that it does automatically if it finds A is failed. That failover might take 3 to 5 minutes, or it
Okay.
might be faster depending upon the load. So
Okay.
in that moment, all the requests from here, this ODBC IP will go to this prod B. I mean, as a developer, you should not be getting into all this because all you need is this IP address and a port number. That's it.
Okay.
What I have on the top was the storage, 8 disk enclosures. Now one disk enclosure is equal to 24 disk, is like 4 disks. Now 8 disk enclosures have 96 disks, where one disk is nothing but 1 terabyte.
Right.
What I have on the bottom is I have chassis 1, I have a chassis 2. Now each chassis I have 6 blade servos. One blade server is nothing but I have 8 CPU plus 8 FPGA plus 16 GB RAM. These are the initial twin fin architecture. So together I have 12 blade servers here, 96 CPU, 96 FPGA, 192 GB RAM. So the bottom line here is for every disk you have, there will be 2 GB RAM, 1 FPGA plus 1 CPU. This is like a node 1. For second disk coming from the 96 disks here, and it will be having another 2 GB RAM, second FPGA. It can be any FPGA. There is no physical bind. Like this, what you have is you have 96 disk, 96 second GB RAM plus FPGA plus CPU, no 96. In this we have a 96 small computers within this twin fin architecture.
Got it. Okay. And you said that each blade server is a quad core processor, right?
Yeah, it is a quad core. So each blade server is a two quad cores. CPU we have. So
Okay.
I open that. That's for twin fin. Okay, Striper has like 8 cores. Right. So this is how a blade server look like. If I open it in middle,
Okay.
this is a quad core. 2 into 4. Quad is nothing but 4. 2 into 4 is 8 CPUs.
Okay.
So where are these guys placed? These are placed here at the bottom. But what happened in the later releases was instead of keeping 2 into 4, two quad cores, the next blade servers were so advanced in such a way that you can keep 8 here.
Okay.
So instead of 2 into 4, we are keeping 2 into 8.
Okay.
Now once that is done, so this box is becoming empty. So Netezza changed its architecture in such a way that instead of keeping 12 blade servers, they are now keeping only 7 blade servers,
Okay.
and they are filling up this space with even storage as well.
Okay.
So there is a little tweak here, and that storage, instead of 1 terabyte storage, they are keeping only 600 GB storage here.
Okay.
So
So
that,
that is after the twin fin architecture. That is from the Striper and Mako.
yeah, in a Striper and Macro.
Okay.
Now in summary, here if I put some more terminology, so these blade servers are also called as SPUs. First of all, here S stands for snippet. SPU stands for snippet processing unit. Since these blade servers process snippets, small queries, we call it as a snippet processing units,
Okay.
right? And 4 disk enclosure plus chassis one is called as a SPA, snippet processing array 1. 4 disk enclosures. 1 to 4 disk enclosures. And 5 to 8 disk enclosures plus chassis 2, SPA 2, snippet processing array 2. When someone says I have a full rack, it's nothing but SPA 1 plus SPA 2. So
Mm-hmm.
this whole combination of twin fins Netezza system is Netezza's twin fin system is one rack. That means all the slots are full. So that means
Okay.
one rack at a high level I can simply say it as SPA 1 plus SPA 2.
Okay.
What is SPA
So SPA.
processing array? SPA is a combination of storage plus processing power.
Okay. So 4 disk enclosures plus one chassis.
Yes,
So that means 6 blade servers is combined as SPA1.
power. Okay, this from
Oh,
hardware
okay.
point.
Okay.
Now, you don't really have to go and buy this full rack, right? So if you go ahead
Right.
and bought the off rack, what we get is you get only SPA1.
Right.
SPA1 means you get only 4 disk enclosures plus 6 blade servers. 4 disk enclosures is 4 into 12, 48 disks. 6 blade servers is 6 into 8, 48 CPU, 48 FPGA, 90, 90, what is that? 96 GB. Well, everything will get just halved, just become
Correct.
when you compare with full rack.
Okay.
Not this one. Right. Now the interesting thing here is that got changed in Striper and Macro. There is no 1 is to 1 is to 1 ratio. What is this 1 is to 1 is to 1 ratio? So if you look at this half rack or full rack or 2 racks or n number of racks in twin pin architecture, for every one
Mm-hmm.
there is an associated one FPGA, there is one associated CPU. Of course, there is somewhere like 2 GB RAM. If you take that out, we simply call it as a 1 is to 1 is to 1 ratio.
Okay.
But this ratio was no longer there from a striper. After IBM acquired it in 2009, what they have done was they have done a pretty good research and realized that the disks are streaming very low and very less, and CPUs and FPGAs are waiting longer. So they changed the whole architecture. I mean, the look and feel of the interfaces are same, but internally from hardware point of view to give them more performance. Now they are allocating more disks to the combination of FPGA and CPU. Now what
Okay.
is FPGA here? Field programmable gate array. Now how they look like is, like I said, we have a diagram here. Let me pull up a diagram. Just give me 1 minute. This is a striper model.
Okay.
Right. So what do I got here is instead of 2 chassis at the bottom like we have it in twin pin architecture, now the chassis
Mm-hmm.
is only one. So instead of six
Okay.
blade servers within it, we got like 7 blade servers,
Uh-huh.
and the leftover space was used by disk enclosures now because the size of hardware components is coming down day by day. So that's the advantage
Okay.
IBM took it, and they giving more storage here. How they are giving more storage? Just by utilizing this leftover space in a full rack.
Okay. So
And
disk enclosures. Okay. So There are no change in the hosts. The hosts are still 2 hosts will be there.
That's G2 hosts. They got some powerful hosts and they got like more memory and processing, but that doesn't affect any developer at all.
Okay. So what is this configuration here, here, Ravi? So this each disk enclosure again will have same 12 disks, and each disk is again 600 GB. You're saying?
Right. So that got changed a little.
Uh-huh.
I think now instead of 12, they got 24.
Or
20,
24 disks.
yeah, they are 24 disks. 6 here and 6 here. What's that number? 24, yeah. Each one got like 24 disks instead of.
Okay. So each disk enclosure is 24 disks.
Right. They got like
And they
6 disk enclosures, 2 hosts, again 6 disk enclosures, 7 S-blade servers. Now under 6 disk enclosures, now here 1 disk enclosure is equals to 24 disks, but only 600 GB.
uh,
So instead of 1 terabyte heavy storage, they got 600 GB high performance.
okay.
So total they got like how many? 12 disk enclosures, 288 disks. The 288 only 240 are used for storage, remaining are for operating system and some other purpose. Space remaining are. So I got like 240 disks. 7 multiplied by 16, how much is? 7 multiplied by 6. So approximately how much they are coming is 240, approximately 2.14 disks they are allocated for each server. Approximately 2.14, 2 point, approximately 2 or 3 disks randomly they are giving it to each blade server.
Okay.
The way this 16 came in the sense here the blade servers are advanced in such a way that instead of 2 into 4 like here 8 CPUs, they got now 16 CPUs. I mean the bottom line is explained here. So Striper is like 3 times faster than
Okay.
twin pin. So there is no 1:1:1 ratio in Striper. So approximately.
Okay.
And one important thing they did was they took out the quarter rack configurations from here. It's only half rack starting.
Okay. So Twinfin even had that quarter rack.
Yeah, Twin Fin had a quarter rack, but Striper starting itself is a half rack.
Okay.
But these
Okay.
configurations are not going to change any of the, even if you upgrade from Twin Fin to Striper, it's not going to affect any of your development stuff at all.
Okay. So here, what is one blade server here? There it was like 8 CPUs plus 8 FPGA plus 16 GB RAM.
Right.
So here one blade server is
It's something like 16, it is exactly double, 16 CPU to 16 FPGA.
okay.
Approximately, I think each one is, there are 8 memory slots. I think each one is capable to hold 4 GB or something. that it is. I don't remember it.
Okay.
But this is for sure. It's a double.
Okay. Okay. Got it.
Now the one we are doing the setup is on TwinFin 7.1. That's the
Okay.
Striper model. It's hardly going to differ, between Striper and Macro.
Okay.
But at
So
least
Striper is overall 3 times faster than the uh,
TwinFin.
twin fin. So in the markets right now, we have most of them are Stripers, Ravi.
Right, TwinFin, I believe it was out of support by now. It,
Uh-huh.
it should be Striper or Macro.
Okay.
Hardly you see any Mustang. There won't be any Mustangs. It's been out a long time. It
Okay.
should be either twin fins or I still know some companies that use still twin fin, but pretty big out there are from Striper or Macro.
Okay. And what about macro? What is the difference there? Yeah, architecturally, any difference is there?
Yeah, I don't see any architectural difference, but they have added some advanced stuff to Macro. So it's definitely a
Okay.
hardware refresh. In the sense, latest hardware they kept it in there,
Okay.
and they added some new features such as Headrow support, multi-stream, restore, and things like that. They added new features to it.
Okay.
More security point of view. So, and disk level encryption. What if someone gets into a data center and just pulls out all the disks from the appliance and try to decode the information from the disks? So it's not possible now with 7.2. It's called macro. So more
Mhm.
focus on the security.
Mhm.
Some features added. I mean, definitely get the best hardware there for sure.
Okay. So that ratio we are talking about in TwinFin, 1:1:2 ratio,
Mhm.
that is nothing but the CPU versus, I think that is storage versus CPU versus FPGA.
That is true.
Okay, so one disk enclosure,
There are disks.
uh,
Two disks.
okay, number of disk, one,
Right. This is the equation.
okay, okay, two disks and one FPGA and one CPU. That is what we, and this does not be followed in the Striper model.
This is the stripe.
Roughly, it will be
No, this is a striper model only. In a twin fin
okay,
model, you got one disk versus one FP. In this twin fin, 1:1:1.
okay,
Or it's multiple disks.
okay, got it. One disk is one FPGA plus one CPU there.
Yeah. For every disk, you have associated FPGA and associated CPU.
Okay, got it.
Now, what kind of a questions you can expect on this in a certification is how many disks there are in a in a striper model. I
Okay,
mean, they don't get into the numbers, so the certification is common for both DBAs and developers.
okay,
Right? Pretty much they ask you at a high level. And it's
okay.
good to know. One second, let me pull if I have any.
So when it comes to host, there is no change, right, Ravi? So host, there are two hosts there in TwinFin and two hosts there in the Striper. Both are Red Hat Linux hosts. So there are no changes there in the failover mechanism and all. There is no change. Only the difference is in the storage and the S-Blade servers.
Yeah, that is true.
Okay.
Now here look at the question number 29. The answer is wrong, but don't worry about it. What are
Okay.
the primary components of S-Blade? This can be one of the certification questions.
Okay.
So if you look at the options A, B, C, D.
Right.
And
C is the right answer.
yeah, CPUs and FPGAs are the right answer.
Okay. But by the way, what is FPGA? Ravi, you said something about FPGA.
Right. FPGA is a class of processor only. Now what it used to do in front of the CPU was it filters unnecessary data. For example, if I have a customer data like let's say the student data, student ID, student name, student gender, student city, 501, Ravi, mail, Hyderabad, 502, mail, Chicago. When someone runs a query, select student name, comma student gender, from student, where student city equal to Chicago. Now if you look at from storage point of view, this data gets stored in a disk, right?
Okay. Right.
Yeah, the moment data comes out of a disk, in a traditional database systems, all the data will go and sit in memory or in the streams. It flows from disk to memory. So this is a traditional system. So from disk here, the data goes to memory. Memory only your CPU works. Your CPU is capable to only work on memory.
Okay.
What used to happen is if let's say I'm joining the student table with other table called marks, student ID, student percent. This join used to take place first, then the respective filtration used to happen after the join. For example, here I have a 2 million records. Here I have another 2 million records. The join used to take place first, then the filtration happens by CPU.
Okay.
So instead of that,
Right.
now another component that got introduced here is why should CPU work on unnecessary joins? So there is a component called FPGA comes in middle and says that let me filter unnecessary data.
Okay.
Here if you look at in the query condition, there is a where class and there are only projections for 2 columns.
Correct.
Why should I send all the 2 million records to CPU? I can filter out 1 million
Okay.
records right away because they are looking for only city and Chicago. There is only 1 million records satisfying it. So let's take out all 1 million records out of it. So
Okay.
that kind of a filtration, a quick analogy is like my gate watchman,
Hmm.
security guard. So he filters out unnecessary people entering from outside into my apartment.
Okay.
If I am throwing a party, I give him instructions saying that, buddy, send only people with so and so conditions matching.
Got it.
right? Yeah, that's what. So this FPGA again, like I said, this FPGA was not something that IBM or Netezza designed. It was it was from a company called Xilinx. So this is actually called as a secret sauce for Netezza's performance. It actually reduces the load on CPU pretty heavily.
Okay.
Huge difference here when you join against 2 million, against 2 million. Here you just join against like 1 million multiplied by 1 million. Also, also in 1 million, it's not about all the columns here. We are only
Correct.
talking about two columns that are getting
Correct.
populated. Or of course the third column also city here. So filters out one unnecessary column from going to CPU.
Hmm.
So it filters
So
out.
this was
Uh,
okay. This was not developed by IBM or Netezza, right? You said some company, Ravi. What is it?
Xilinx, Xilinx. This was a company that
Oh,
makes
Xilinx.
FPGA.
Xilinx.
Xilinx.
And Netezza bought this company.
Yeah, they are buying these only FPGA components.
Oh, okay.
But these guys sell FPGA. Like Netezza took RHL source code from Red Hat.
Hmm.
If you look at the whole components, what Netezza did, in my opinion, was they put together the best, and from the best they took out unnecessary stuff, and they released their first appliance
Hmm.
for only the data warehousing market.
Okay.
Let's quickly go through some of the questions. Just to these are not at the same. These are not at the same toughness as the real certification, but here is a link. I will share you this PPT. Here is the link where you can see it is a certification information. They ask you the 67 questions and they give you 90 minutes and passing score is 63% needed.
Okay.
So let's look at like some 3, 4 questions. These are not real certification questions are at the same level. Just helps you understand the basics.
Okay. I think this is all of the above, right?
That is true. It's a appliance and it's a black box solution. It's an appliance for analytics.
SPA. Split is also called, I think, SPA.
SPU stands for
Snippet
Snippet Processing Unit,
Snippet Processing Unit.
Snippet Processing Array. Let's go back to this. Yeah, yeah.
Okay.
Yeah, this might be a little confusing. SPU, SPA, RAG. Right, SPU is the
Right.
blade server.
Blade server. Okay. Snippet Processing Unit. Okay.
Yeah, absolutely.
Okay. This is FPGA. You said just now. You said about it.
The FPGA.
Secret sauce for the Netezza. Yeah. What does FPGA stand for, Ravi?
It's a field programmable gate array. It's
FPGA
like
is what? Fail?
field programmable gate array.
Gate array. Okay.
Question number 4. This is little lengthy one.
Okay. NPS. NPS. What is NPS? Network interface cards. Network processing. Netezza performance server. NPS is. and SPU is snippet processing unit, SPA is snippet processing array, S-blade is what? Snippet blade. Yes, blade is snippet blade. NIC is network interface card, could be. FPGA is field programmable gate array. That is what you said just now. AMPP is asymmetric massive parallel processing. SMP symmetric multi-processing. CPU is CPU, central processing unit.
True. Our hosts are called as SMP hosts, symmetric multi-processing hosts, because they process multiple things at the same time. And our
Okay.
whole appliance is called AMPP appliance. It's asymmetric massive parallel processing.
Okay. The whole unit of the whole
Whole,
black box is called a.
yeah, called as AMPP. It's not just Netezza. All the appliances in the category, same category, are all AMPP boxes.
Okay.
So the Netezza used to call it as NPS, Netezza Performance Server, in the olden days. Still stays there, the terminology. You know what is SPU, now you know what is SPA. S-Blade and SPU both are same. NICC is for communication. FPGA is another component, of course CPU. There's various hardware components.
Okay.
I mean, from next year it just starts with the real stuff. So this is just to cover on the initial recap.
Okay.
I will stop here for today. Our next immediate thing is to have the setups ready.
Okay.